Okay, let's look at the section 2.6. This section talks about biconditionals. Right? Biconditionals are basically if and only if statements. So this is same thing as if and only if. Remember that the IFF is the short notation for if and only if. Right? So notation wise, we can say something like a P with the both-sided arrow, so kind of a fat both-sided arrow, and Q. So P, if and only if, Q. Right? So this is defined the same thing as it's a bi indicates that it's a both-side conditional, so it's actually a conjunction of P implies Q, and also with the Q implies P. Right? So it's a two-way implication, basically. Right? So let's look at that. So since this is defined as two-way implication, so you can see that let's look at the all four possibilities. So let's see, true, true. Right? So P implies Q is true. True, false. P implies Q is false. False, true. Implication is true. False, false. Implication is true. Right, the other way around. True implies true. True. False implies true. So that's true. True implies false. That's false. Right. False implies false. That's true. Right. Then biconditional is the conjunction of these two guys. So true and true. So that's the only way it can be true. False, true. So that would be false. Right. True, false. So that's false. Right. And true, true. That's true. Right. So if you pay attention, biconditional is basically when P and Q are either both true, then it's true, or both false, then it's true. If they have different truth value, then it always gives you false, right? So that's the biconditionals, and so it's the same thing as if and only if. Right? And another way to say it is actually necessary and sufficient, right? So maybe I should explain if and only if first too. So this is the equivalent of saying that if P if and only if Q, right? Sometimes I get confused on which is which. If, right? If is the implication this way. P if Q, so the implication is actually this way. Q implies P, and only if is the other way around. So this the P implies Q implication, right? Then we can also say P is necessary and sufficient for Q. All right? So necessary, right? So P is needed for Q to happen. So if Q happens, P should be there. So the implication is actually this way. Q implies P. And the sufficient means that P is enough to make Q happen. So P implies Q. Right? Those are the implications. All right? That's it. I hope that this was clear.